Sorry, I'm just thinking how I want this to work. So is that a quadratic inequality? Yes? I mean, it's an inequality, right? It contains x squared, so it is a quadratic inequality. Now, it isn't all like equal to 0, or sorry, it doesn't have all the stuff on one side and 0 on the other, right? But it still is a quadratic inequality. So now we want to try and solve this, right? So how do we solve it? What's the first step? We'll get x by sub, yes, but hold on. We're going to first just turn it into an equation, right? So we're going to forget the inequality for right now. We're just going to turn it into an equation, and then we're going to solve that equation. So I'm doing these steps right here. First step, turn it into an equation. 8x equals x squared minus 12. And now you have to know how to solve that. That's a quadratic equation, and so we want to get everything to one side. Yes? How did you move it? I just
like I subtracted the 8x
on to that. Yes, you could do that. Yes, you can subtract. You just can't. If you divide, then there's divide by negative. It's going to flip things over.
I just made it.
So you just turned it into this first.
Yes.
Did you put the 8x in the middle? Yeah, you could do that first. But and actually, that's what I'm about to do right here. Right, I'm about to move that 8x over to the other side and make it like this. So subtracting 8x on both sides, I get that. And now you have to solve this. How do you solve that? You try and factor it if you can. And I think I made it where it would not factor, or does it? It's not going to work. 6 and 2 don't work because, yeah, 6 and 2 don't work. Right? Yeah, you'd have to have different signs. So what does that mean then? Quadratic formula, right? So I need the quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So a is 1, right? B is negative 8, c is negative 12. So negative b, the opposite of b is the opposite of that. That's 8 plus or minus. That negative 8 squared is positive 64 minus 4 times a times c all over 2 times a. And then I just got to work that out, right? OK, so let's see. This is 8 plus or minus square root, let's see, 64. And because this is a negative, a positive, and a negative, when I multiply all those together, it should be a positive. So I know I'm going to have a plus, and what is that multiplied together? 48? 48? All over 2? 8 plus or minus the square root of 112? All over 2? Do you have questions? Am I going too fast through that? All right, get my calculator out. Square root of 112. 10.6, good enough? 10.6? So I have equals 8 plus or minus 10.6 all over 2. And now I'm going to get those two answers. So 8 plus 10.6 divided by 2. 9.3 is one answer. And the other answer is 8 minus 10.6 divided by 2. Negative 1.3. Can somebody confirm, is anyone doing this with me or no? Yes, does it look all right? Okay, thank you. All All right, so we've got these, right? We've got these, and now what? I solved, right? I solved it. Step one's done. Turn it into the equation and solved it. Now, I'm going to draw a number line. I'm going to plot those answers. Make sure I get them in the right order. Negative 1.3 is back here somewhere. 9.3 is here. This creates like a natural, what we call partition of the number line into 3 sections. And now I'm going to check each of the 3 sections. And so I get to pick my choice, 3 points to test. I'm going to go ahead and go with negative 2 over here. And because this is negative and that's positive, 0 is in here. Doesn't matter that it's not like drawn properly, just as long as you get a number that's in there. And then over here, let me go with 10. And what am I going to do with those? Plug them in for x into where? Where am I testing this? The original inequality, right here. I'm going to go right in here. Don't go working with this, okay, because you're not working with the equation. You're not testing the equation. You're testing the inequality. So now I'm going to plug it in here. Or you could plug it in here as well, right? If you had moved the 8x over, you could do that as well. I always recommend going back to the original one just in case you made a mistake. Like if you messed up somewhere here, then it's going to throw everything off. So I'm going to go back up to that. Let's test. Let's test x equals negative 2. Let's plug that in to there. You get 8 times negative 2. Is that less than or equal to negative 2 squared minus 12, right? That's what I'm checking. This is negative 16. Is negative 16 less than or equal to, what's that, 4 minus 12? So is negative 16 less than or equal to negative, what is that? 8? Is that true?
Yes.
No? Yes? Yes? No? Think of a number line, right? Where's negative 8? Where's negative 16? Is this smaller than this? Yes, because it's to the left of it. You have to be careful with negative numbers, right? It's left and right on the number line. This is true, right? This is true. Which means this region works. And then you plug in 0 and test again. If we plug in 0 and test, it will be no, and then it will be yes. So I will tell you this, on a quadratic, okay, it will switch. Okay, so if this works, you know this one won't and this one will, all right? I withdraw that statement. Let me withdraw that statement. I don't want you to go down that way. I don't want you to go down that way. I could come up with a quadratic where it would work. Yeah, I could come up with one where it would work and work. Yes?
I was going to say, so whenever you do the lines, don't you have to do a full circle?
Yeah, okay, so now we know this works. I showed that. Check for yourself, 0 does not work, and then 10 does, all right? I'm not going to show those. Is that all right with you? Okay, so now the question is, what do we include? Well, we know everything over here works, but do we include the negative 1.3? Well, negative 1.3 is what made the quadratic equation equal 0, right? Do we want to include that? Well, the original inequality had the bar underneath, which means it's okay to be equal to 0 as well. If this bar is gone, I don't want to include that point. If this bar is here, I do want to include it. So I will put a solid dot here. And for the same reason, at the 9.3, I include the 9.3 and everything to the right of it. And so my final answer to this for my solution, right, for this inequality, quadratic inequality, is negative infinity to negative 1.3 bracket union bracket 9.3 to positive infinity. How are we doing? All right, so try the homework. That's it for this section. All right, this is 4.5. So that's the homework right there for 4.5. Solve the inequalities. I think these are pretty straightforward problems. There's, I think, 5 problems there for you to do. Look at number 21. That one may look a little weird to start, number 21. But just distribute the 6 through the parenthesis, and then it maybe won't look as bad, right? I'm not sure why they gave you that problem, but distribute the 6 through and just work on it the way we just did. Okay. So right now, as it sits, we should be comfortable graphing a line in this class. We should all be able to graph a line if I gave you the function that was linear. And we should all be somewhat comfortable graphing a quadratic function, right? And we have this little side topic that we just went over, that if we have a quadratic inequality, we know how to solve those as well. We're now going to move on to the next part of types of functions we want to be able to graph, and that is polynomial functions. And I do think this is where things start to get pretty bumpy, all right? Because all the little cute formulas we've had, and quadratic formula and all that stuff, it starts to go away now, and we don't have as many powerful tools when it comes to dealing with these types of functions. And every one of these is just unique. So let's just recap here. If I give you this function, could you graph it?
Yes.
Yep. What type of function is that? Linear, right? Can we recap how to do this? How easy it is for us? Should be?
Place point in y, -4.
Go to your y-intercept of -4. 1, 2, 3, 4, -4. From there,
Draw a line from it.
slope. Use your slope as 3. 3 over 1. So you rise 3 from here. 1, 2, 3. And you go to the right 1. Draw another dot. Draw a straight line. And you're done. That's a linear function. Okay, the next function. Quadratic, right? Could we graph this? Yes, okay, we know how to do that. I'm not going to go through that problem. We're done with that, right? Now we move on to the next type of function that we should be able to graph, which is the polynomial. And this linear function, when we tried to generalize it back when we were learning them, is we say, hey, what we can do is we can say f of x equals mx plus b, where b is the y-intercept and m is the slope. That look familiar? And then when we get to the quadratics and we try and generalize that, we say, oh, this is like f of x, the general form is ax squared plus bx plus c, right? It's some number in front of x squared, some number in front of x, and then some number by itself. That's the standard form, right? Of course, there's a vertex form, but this is the standard form. So it seems like the next thing we should study should be when we have x cubed, right? And then maybe after that, x to the 4th, x to the 5th, x to the 6th, right? That seem natural? What we do instead, though, is we say, okay, you know what? Instead of doing 3rd, 4th, 5th, 6th, let's just study all of those at the same time, okay? So we're going to have a more general formula for this. It's going to look like this, all right? But we're going to run into some problems when we try and write it this way. So let me give you some examples. Before I give you polynomial and we get into like the definition, let me just give you some examples of polynomial functions. So here's an example of a polynomial function. Ready? That's an example of a polynomial function. Wait a minute. What kind of function is that? It's a linear function. So I'm now telling you that a linear function is actually a polynomial function. All right? Here's another example. That's quadratic. But that is also a polynomial function.
Isn't a polynomial anything with a variable?
Yeah, so what is a polynomial? Well, let me give you another example of a polynomial function. There, that's another example of polynomial function. Let me give you another example. That's a polynomial function. Here's another example. That's another example of polynomial function. What we want to be able to do is sketch these, right? To sketch any of them. Like someone gives us one, we should be able to draw it. It's much easier for us to do this because this is a very limited case, right? X squared, quadratic. We've got the 6 steps, all these beautiful things. Over here, super easy to graph. But what if we just like totally blow it out the door here and just be like anything that looks like anything like that? Like, do y'all see we're not going to have like a nice set of steps that are going to be like, I mean, we are going to have a set of steps, but do you see it should probably be pretty challenging to do this in general? Like for anything anyone gives me, right? So there are some things here I need to point out about all of these. When you look at all of these, they all contain x's to powers, right? There's something about all of those powers. They're all non-negative integers. Okay, non-negative integers. What are the integers? Do y'all know what the integers are? Integers. Oops. Let me just start over. What are the integers? Integers are 0, 1, -1, 2, -2, 3, you keep going forever, keep going the other way forever. Those are your integers, right? That was the thing I showed y'all with the z, right? Notice that all of these are integers, aren't they? All these powers are integers, and they're all not negative, right? They're all not negative. You need that to be a polynomial, okay? To be a polynomial, all powers on all x terms must be non-negative integers. If I put a negative up here, if I made one of these powers like if I made that -7, or if I made that -2, or I made that like -1 or something, if I did that, it would no longer be a polynomial function. It would be something else, which you will study in Calculus 1. Okay, in Calculus 1, we go even further than this. We go, of course we do polynomials, but we then just say, well, let's take away the restriction of the power having to be positive, and let's just look at like functions in general, like anything you can come up with. How do we graph those? But that's for another day. Okay, so that's a couple of examples of polynomial functions. Also, I want to point out, I'm going to put a box around this in red. Now, all of those numbers that are in red are the highest powers of the x that you see in each one of those, right? Like the highest power of x here is 1. The highest power of x here is 2, 3. That was an 8, right? 8, 7, yes? That number, this number right here, this number right here, this number right here, is called the degree of the polynomial. It's the degree. It's the highest power of x. The highest power of x that you see is the degree of the polynomial. The degree of the polynomial is going to tell us a lot about what the graph looks like, all right? There's something else here that I want to point out that's going to become important to us, and that is in front. So this is the degree, right? This is a degree 1 polynomial. The number in front of that highest power of x, that number right there, or here there's a 1, here there's a 1, here there's a 1, and here it's a negative 3, right? You see that number right there? That number right there is called the leading coefficient. And the leading coefficient, together with the degree, these two pieces of information are actually going to tell us a lot about what the graph looks like. Okay? It's going to tell us a lot. So that's why when I put these up here, I want you to be able to identify them. So let's see if y'all understand. What's the degree of this polynomial? 1, leading coefficient. 3. Degree, leading coefficient. Degree, 3, leading coefficient. Degree, leading coefficient, 1. Degree, 7, leading coefficient, negative 3, right? One more. I don't think I'll trick you, but I'm going to try. Is that a polynomial function? Yes? Yes, it is. What's the degree? 6. What's the leading coefficient? Negative 7. Highest power of x, 6. The number in front of that highest power is the leading coefficient. Y'all got it? Degree 6, leading coefficient, negative 7. All right. I'm going to erase this. So when it comes to polynomial functions, just like we had this a second ago, this was our generic, this was the generic standard form of a quadratic. I'm about to show you the generic standard form of a polynomial function, right? And it's not going to be pretty. Here it is. So I'm just going to write it. F of x equals, okay, I'm going to do it where when I write this, I'm going to have, just like here, the highest power of x is going to be first, and then I'm just going to go down with the powers. So if this is a polynomial function, I'm going to have an x here. Do y'all agree? And then it's going to have a highest power. Now, what is that highest power? It can be any non-negative integer, right? So I can't like put here 100 or something like that. I'm just going to put n. That's some number that I don't know. It just depends, right? Depends. Now, it might have a leading coefficient. Does that leading coefficient have to be a 1? No, it can be any number, right? So how do I say any number? Well, kind of like here, couldn't I put an a? Yes, I could. I could, right? Let's try it. I'm going to put an a here. A in front of that. Okay, plus. Now, I'm going to have x to a power again, right? But that power cannot be that big, right? It's got to be 1 less than that, right? 1 less than that. So I just put n and I take away 1. And then that's going to have a coefficient too, and I can just put a b here, right? And then I continue, I have x to the power n, but now I need to take away 2 from that power. And then I'm going to have some constant in front of that, c. Do y'all see what I'm doing? Do y'all understand that? Now look, do all of these, look at this one right here. This one right here, if we were to use that format, what would a be for us here? What would a be? Negative 3. What would n be? 7. Do y'all see an x to the 6th here? No, this formula looks like that I should have an x to the 6th, right? I do, but what's b? B is 0. Do y'all see here there is, sitting right here, a 0 in front of x to the 6th? Right? And there's also a 0 in front of x to the 5th, and a 0 in front of x to the 4th, and a 0 in front of x to the 3rd, and then a 1 in front of x squared. See what I'm saying? So this formula, even though some of ours are missing some of the powers of x, the general formula should include every one of them. Following still? Keep going. What would the next one be? Plus dx to the n minus 3. Yeah? And then I keep going and going and going and going and going all the way, plus I have to put dot, 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 because I actually don't know how many of these I have, because I don't know how big n is in general, right? But I know that my very last one, let me put it over here, my very last one is probably just going to be a number by itself, right? And so what letter should I put out here? Z? Do you understand the last one is a number by itself? So it should just be like Z? And we can't use N because we're already using N. See, do you all see the problem we just ran into? This is a big deal. What letter do I put out there? I don't know. I don't know how many I had, right? I don't know how many I had. I can't say Z because that implies that there's like 26 of these, right? A, B, C, there's 26 letters in the alphabet. We have a major problem because what if this highest power is 100? Then can you do A, B, C, D, E, F? You're going to run out of letters, aren't you?
Then you start combining letters.
Combine letters, like how?
Like A, B.
A, B, A, B, C. So do you all see that mathematicians ran into a problem right here, trying to generalize this? And we said we can't use A, B, C, D because it's going to fall apart as soon as our polynomial gets too big. So what we did is we said scratch that. Scratch that. Let's not use letters like that. Let's use this. This first one, I'm going to call it A, but I'm going to subscript it with an N. That's A sub N. That's still just a number, but I'm using a subscript instead of just using A. This one is A subscript N minus 1. This one is A subscript N minus 2. This one is A subscript N minus 3. And if I do that, then what should my last, very, very, very last one be? A subscript what? What happens when I get to the very end? N minus N, which is 0. I get all the way to the end and I have my, this will be 0. And the one in front of it will be A sub 1 x to the first power. Read it from this end. You have just a number, right? Then you have a number in front of x, then a number in front of x squared, then a number in front of x cubed, number blah, 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 and then you get all the way up to the highest power. You don't look like you like that. Nobody ever likes this. Subscripting. Yeah, it starts to look very ugly, right? It starts to look like math. That looks too mathy, doesn't it? Let me put this one up right here. I'm going to give you a specific example. Let's look at this one right here. 3x to the 7th plus x squared plus x minus 5. Okay. This is, what's the degree of this polynomial? It's the 7th power, right? 7th power. So if I were to be looking at it with something like this, it would have to look like this. A sub 7 x to the 7 plus a sub 6 x to the 6 plus a sub 5 x to the 5 plus a sub 4 x to the 4 plus a sub 3 x to the 3 plus a sub 2 x squared plus a sub 1 x to the 1 plus a sub 0. That is the generic formula for a 7th degree polynomial. For ours, what is a sub 7 for us? Negative 3. What is a sub 6? Well, there's no x to the 6th, so that's a 0. What about a to the 5th? 0. A to the 4th? 0. A to the 3rd? 0. A squared? 1. A sub 1? 1. And a sub 0? Negative 5. Does that make more sense? This is the generic formula for a polynomial function. You give me a power, and then it's going to look like that. All right, and our goal is to be able to graph it, right? Like, how in the world are we going to graph this? So I have 4 minutes. I want to just try and get this last little thing in, all right? That's the generic formula. What do these look like? What do polynomials look like? What do polyfunctions look like? All right, we know what a parabola looks like, right? We know what a straight line looks like. But what do they look like in general, like generically, all right? Here are the two main properties of polynomial functions. First of all, they are what we call continuous. What does that mean? When you draw them, you can't pick up your pencil, all right? You draw it, you'll never have to pick up your pencil. That's the first thing. They're continuous. The second thing is if the n is greater than or equal to 2. That means you're talking about a quadratic and higher. Then I can tell you that it's going to be smooth, and curved. So think about a parabola. Is that smooth and curved? That's when n is 2, right? That's when n is 2, it'll look like that. Now we will have to look at these, we're going to look at these next class, but I'll show you. If n is 3, it's probably going to look like this. Something like that, or it can maybe look like this. Okay, but do you see with these graphs, these are smooth and curved? Draw it without picking up my pencil. If n is 4, it's probably going to look something like this. Or it might go, I don't know, might do something like that. You're just taking my word for it, that these are smooth and curved, all right? So they look almost like roller coasters, all right? That's what polynomial functions look like. And in the real world, remember how I was telling you about, like, you know, we were throwing things around in the castle and the satellites, parabolas are useful? Anything you can think of in the real world that does some oscillation up and down, like anything, weather, temperature, stock market, anything that does that, right, you can use polynomial functions to model that. So that's why we study them, right? All right, so for the weekend homework, make sure you do the 4.3 and 4.5 homework on quadratic functions and quadratic inequalities. Otherwise, I don't plan on having a quiz next class, but we're going to get into polynomial functions hardcore next week. We're going to need to be able to do long division and synthetic division. Does that sound familiar to anyone or no?
That sounds vaguely.
We're going to run through it. We're going to run through it in case you don't remember. But all right, have a good weekend. Be safe.
Professor,
Yes.
do you have a minute?
Let me turn my camera off first.
Sure.
Yep. Okay. Oh, yeah, you're good.